is that part of thinking that is governed by the scientific method.
Is work-life balance essential for a person to be successful?
Well, some kind of balance is clearly necessary. You do have to eat, and yeah, it's well, sure.
Okay, I think that's the best.
But there are many ways of balancing one's work and one's life, and my observation is there's not much difference between scientists and other people. Everyone faces this problem. Some successfully, some unsuccessfully.
The results, contemporary, popular media have brought, in connection with the research on the Higgs boson and the discoveries, popular media have brought the word God into sharp focus. Now,
Well, there was a book by a experimental particle physicist, which was called The God Particle, which was a silly name. The story behind that, I'll tell you, that as far as I know, was that this was Leon Lederman was bugged by all these theorists who told him, you have to find the Higgs particle. And so he referred to it as that goddamn particle. And his editor said, you can't do that. So let's take out the damn and just call it the God particle. So if you want to use the word God, let's call it the goddamn particle.
now, this one attempts to draw you out. It says, it's an honor to meet you, sir. Do you believe in God as a normal human, as a physicist?
Well, look, the way I usually answer that question is twofold. As I said, they're very interesting questions that Homo sapiens have been asking. Maybe dogs ask them too, I don't know. But, and some of them are addressable by the scientific method. And some of them are not.
How long has this taken?
Yet, maybe, but are not. For example, why is there something rather than nothing? So I'm really not interested in questions for which people invoke God or some other unscientific method, because it's not very productive, and I don't have much faith, intuition, belief that those questions are going to be answered very soon, and I'm interested in the answers. So the questions that cannot be addressed by the scientific method, for me, I too ask them, but I am not that interested in them.
Sir, give me an easy definition of the string theory, since it is difficult to follow.
Well, I don't think we yet have a theory. We have a framework, a set of ideas that are growing and becoming more powerful. But as I said, one way of putting it, and certainly the way these ideas emerged early on, was the idea that instead of thinking of matter as point-like particles, you think of matter as vibrations of an extended object like a string.
This is for the engineers. Can electricity be generated by using gravitational force? Is the concept possible or not?
Sorry, can what be generated?
Can electricity be generated by using gravitational force?
The force of gravity can't be used for much normally, because for example, that's an interesting question. I've never thought about it. I'm sure I could think of a way that this could be done. But gravity is a very weak force. Some people are surprised to learn that gravity is the weakest of all forces. You know, in the atom, you have electrons, right, and as we were told in the dance, in the song we heard, electrons and the nucleus, and they attract each other, and they also attract each other gravitationally, because they both have mass. So the electron is pulled to the nucleus by gravity in addition to electricity and magnetism. But the force is 10 to the 40 times weaker. That's 10, 1 with 40 zeros times weaker. Some people find that hard to believe because that's the only force they feel. Gravity is the only force I feel, so how can it be so weak? The reason you feel it is for two reasons. One, it's weak. You don't feel electrical forces usually unless you're unlucky to stick your hand in the plug, because electrons and protons interact with this much, much stronger force, so they come together and make a neutral object that doesn't have a charge. And you don't feel the nuclear force because the quarks have a much stronger force, and they come together and form the proton, which has no charge. So because the other forces are so strong, they come together and form neutral objects. But gravity is different. There is no anti-gravity. There is no anti-mass. There are only positive masses. So all particles attract. There's no way of canceling the gravitational force, making neutral objects by bringing them together. They just become more and more massive, bigger force. But because of that, everything pulls on you. And so the reason you feel gravity is, one, it isn't neutralized, there's no anti-gravity, and two, you are acted on by the whole planet. So when I'm holding this up, I'm exerting a little bit of force coming from my muscles, which comes from chemical energy. It really is electromagnetic in origin. And the Earth, the whole planet, every atom in the planet is pulling on this to make it go down. So little me with a little bit of electromagnetic force is resisting the whole planet. Gravity is so weak. So to harness gravity is extremely difficult. You can harness gravity in the vicinity of a black hole. There, gravity is very strong because you have an enormous mass, and quite conceivably you could use gravity in a sense to turn motors, generate electricity near the horizon of a black hole. But you'd have to be very careful not to fall in.
Flipping an up quark causes the proton to lose its charge.
That's a question?
Yes.
Yes.
Could you explain that?
Well, so I talked about the strong nuclear force, which I was involved in, not the weak nuclear force. The weak nuclear force is a force that in many ways is similar to the strong nuclear force, but so the strong nuclear force is sourced by this color. And because of it, actually one color quark can turn into another color quark. The weak nuclear force is sourced by flavor or up-down, and because of it, an up quark can turn into a down quark, or a down quark into an up quark. An electron, which doesn't feel the strong nuclear force at all, that's why you can pull it out of the atom, does feel the weak nuclear force. And so what happens is that a proton, which has two up quarks and a down quark, one of those up quarks can turn into a down quark, and at the same time emit to conserve the charge of the weak nuclear force, and electron, and a positron, the antiparticle of an electron, which has 1 unit of positive charge, and a neutrino. That's like beta decay, it's called. So the proton becomes a neutron, a positron, and a neutrino. Or a neutron becomes a proton and an electron and an antineutrino. And that's what radioactivity is. If you take a nucleus which contains protons and neutrons, and one of the protons turns into a neutron, the atomic number goes down by 1, and you have transmuted it to a different element, different chemical element. So because of the weak nuclear force, you can take lead and make gold, in principle, although it's too expensive to do it.
Or imagine 26 dimensions.
Well, you start 1, 2, 3, 4, 5, 6. So it's hard to visualize until you get used to working with what Descartes taught us, is how to represent space with numbers, as a collection of numbers that tell you how far you have to go out in this direction or that direction or that direction or the other 24 or 3 directions. So with mathematical formula, you can play with any dimension. To construct a visual picture, of course, is difficult. And I don't try, actually.
Thank you, sir, for your very patient and understanding approach to our questions. Thank you.
So by the way, your process really worked, because these were quite excellent questions.
Thank you, sir.